Hello friends, welcome to UGC EPG Pathshala. I am Professor Masood Ahsan Siddiqui from Department of Geography, Jamia Millia Islamia. Today we have to discuss about the map designing aspects. The end product of a GIS is the map, and if the maps are not properly designed, they will fail to convey the message. The term map designing refers to the planning of a map, particularly to the choice and the arrangements of its graphic elements. For GIS, graphic output must show the features appropriately symbolized or labeled, and the relationships are discernible. The map design processes includes making decisions about the selection of geographic features and attributes to be represented on the map, selection of an appropriate map projection system given the purpose of the map and the geographic region of interest, choice of an appropriate scale, selection of appropriate symbolization, and design of the overall layout of the map. The quality of map to a large extent depends on the quality of hard copy maps or the graphical displays. Therefore, design of graphic output is critical if information is to be conveyed in an effective manner to the user. The map design processes is especially important because maps are a synoptic form of communication. The aim of cartographic design is to present the geographical data in such a fashion that the map as a whole appears as an integrated unit and each item is clear and legible. Graphic output from GIS is often poorly designed. For example, there rarely exists any appropriate scaling of colors or patterns. The principles of cartographic design are not considered at all. The map is what distinguishes GIS as a different approach to the management of information, so extra care should be taken to improve the final maps that a GIS generates. The issue of geographic design in GIS has become more important because of the fact that screen displays introduces a new set of issues as it has greater capabilities compared with the paper maps. The concept of designing may be summarized as the purpose of design is to focus the attention of the user. The principle of cartographic designs are timeless. The results are not. The rules of the cartographic design can be taught and learned. Principles and concepts have to be acquired. There are 5 basic principles of map designing. These are: number 1, concept before compilation. Without a grasp of concept, the whole of the design process is negated. Once the concept is understood, no design or content feature will be included which does not fit it. Design the whole before the part. Design comes in 2 stages: concepts and parameters, and detailed in execution. Before designing, few questions to be raised. What does the user want from this map? What can the user get from this map? Is that what they want? If a map were a building, it should not fall over. The third one is hierarchy with the harmony. The important thing must look important, and the important things should look the most important. They also serve who only stand and wait. Lesser things have their place and should serve to complement the important. The third one is the associated items must have associated treatment. Harmony is to do with the whole map designing happy with itself. Simplicity from sacrifice is the key to the map designing. Great designing tends towards simplicity. It's not what you put in what makes a great map, but what you make out. The map design stages is complete when you can take nothing else out. This is the designer's skill. Content may determine scale, or scale may determine content, and each determines the level of generalization, that is the sacrifice. Maximum information at minimum cost is how much information can be gained from this map at a glance. Functionality, not utility. Design makes utility functional. All designs are a compromise. The spark which makes a map special often only comes when the map is complete. The last one is engage the emotions to engage the understanding. Design with emotions to engage the emotions. Only by feeling what the user feels can we see what the user sees. Good designers use cartographic fictions, cartographic impressions, and cartographic illusions to make the map. The image is the message. Good design is a result of the tension between the environment, the facts, and the designer. Only when the reader engages the emotions, the desire, will they be receptive to the map's message. Design uses aesthetic, but the principles of aesthetic are not those of design. An important thing is to be discussed over here is the elements of a map design. The features, symbols, and text, their relative placements, and the process of choosing the data to be placed on the map, given the information to be conveyed, and the audience for which it is intended, balance, contrast, etc. are the key elements of map designing. The proper design for other types of geographic information, charts, graphs, etc. can be considered as a subset of proper map design. Some elements are found on almost all the maps, no matter what the theme. Others depends heavily on the context in which the map will be read. The best GIS database so may be a failure if it cannot be displayed effectively. The figure 1 shows the elements of the map design. These are the contrast I have already mentioned. Contrast is a visual element that determines sharpness of the map. Contrast may be achieved by varying the appearances of the lines, shapes, size, patterns, color, intensity, and directions. A map has a number of linear features such as coastlines, rivers, railway lines, roads, and various political boundaries. In order to distinguish them, it is necessary to vary their characters, shape, size, patterns. Visual contrast can be based on any of the graphic variable through visual contrast, though visual contrast is necessary and can enhance the interoperability of the map, but too much visual contrast can detract from the clarity and order of the map. Pattern is also important. Patterns are composed of dots, lines, or combinations. Every pattern has texture, which is the spacing of the marks, usually specified by the number of lines, dots per inch. The greater the number, the finer is the texture. Number 2 is the arrangement, which refers to the relationship of the positioning of the marks, such as parallel lines, cross-hatched, arrangements of dots. It must be noted that while placing dots, don't follow any defined pattern. The third important thing is the orientation. It refers to the positioning of the arrangement relative to the viewer as vertical, horizontal, or diagonal. And the fourth element, that is the value, which refers to the relative darkness. An important component in modern cartography or modern mapping is the use of colors. The use of colors on map is more than simply a way to construct a legend. Color carries visual meaning, it directs attention, and it can emphasize or obscure features. Thus, color selection is an important element of map design. The human eye can distinguish tens of thousands of different colors, but only 20 to 30 gray tones. The eye is always superbly able to identify patterns and boundaries, that is edges, and to detect movements. On a static map, however, the eye cannot reliably match more than 16 to 20 simple colors from the legend of the map. This limited ability can be expanded by the addition of pattern elements, that is the symbols, to the basic colors. Still, there is a practical limit to how many colors should be displayed on a map. Maps are easiest to interpret when the number of colors does not exceed 10 to 12. Too many colors, more than 20, create a map that is visually cluttered. The nature of the color and human perceptions of colors are one of the most important elements in cartography. Blue, green, and red are the primary colors, also known as the additive colors, because they can be added together to create all visual colors of the spectrum. Colors may also be created by subtracting an additive color from white. For example, white minus red is equal to cyan, that is equal to blue plus green. Color printing newspapers is based on the subtractive colors plus black. whereas color video display, televisions, monitors is based on the additive colors. In printing a color document from a computer display, the printer must translate additive colors into corresponding combinations of subtractive colors. The Munsell color code is internationally accepted standard for describing color quantitatively. The figure 2 is showing the Munsell color scheme. Color has three main dimensions. One is hue, second value, third percent reflectance, lights or brightness, and the third one is the chroma, also termed as saturation or intensity. The three has been implied in Munsell's system. When we speak red, green or blue, in fact we are describing the hue. Value of the color is sensitivity of the color. The tones of the scale value ranges from black to white and referred to as gray scale. Chroma refers to the reactions of the eye to the color. It also refers to saturation, which is the amount of hue in color. The colors on monitor are additive colors. When all the three basic colors are added, this will lead to a white sensation. The standard VGA color monitor can display 16 colors from a total color selection of 2,2144, that is 64 to the power 3, whereas a super VGA monitor can display up to 250 simultaneous colors from a total of several million possibilities. More advanced monitors can display still more colors. Color may vary standardized meanings in particular applications. For example, blue for water bodies, green for vegetation, brown for desert and mountains, contours, white for ice or snow, etc. A standard scheme is often used as on geographical maps. Green for Cretaceous rocks, yellow for quaternary, blue and green for areas below sea level, green and yellow for lowland and hills, brown for mountains, red for forest areas over 5,000 meters, etc. The effect was meant to be that areas appeared to be the nearest to the viewer were in fact farthest from the sea level. The sequence of colors in a legend serves an important function in showing the visual relationship of map features. A smooth sequence of colors is best for showing data that are continuously variable. It is recommended that instead of varying colors, vary the tones. Dissimilar colors create visual barriers between features that are not related to each other. Balance is another important characteristic of a map. It refers here the distribution of elements as evenly as possible within the map frame to avoid unnecessary crowding and conversely large blank areas. In other words, the relationship between the visual components appear logical and the map is legible. The most important element in a given design should be featured in more prominent positions and occupy larger areas within the frame. It is advised that the most important information should be featured near the top or to the left of the map. Less important and ancillary map elements can be positioned towards the bottom and right. In this way, the importance of the various map elements can be matched to the visual hierarchy of the map itself. Visual balance is affected by the weight of the symbols, the visual hierarchy of the symbols, and the elements. All these characteristics are shown in figure 3. The title of a map is very important. The title should be written in a larger font than any other supporting map. Text or annotation. It may be in bold type or greater emphasis. The title has to be placed at the top of the map. It is often useful to include location of the map elements in the title. Never use abbreviations or unspecified acronyms in the title. Legend, which is a clue to the map legend explains the meaning of the point, line and area symbols used to represent features on the map. Every symbol that appears on the map must appear in the legend and it must appear exactly as it does in the body of the map. Legends are generally used for depicting qualitative data, whereas for quantitative data, the term index is preferred. The element of visual hierarchy perhaps is the most important design decision to ensure that the relative importance of information shown on the map is reflected in the choice of symbolization. Unnecessary information should be eliminated and relevant information be symbolized in a way that makes more important information visually more prominent. This requires careful consideration of the map purpose, as maps with different purposes may display the same geographic features but with different emphasis. The visual hierarchy of a map can be enhanced by manipulating figure-ground relationship. The human eye brain system automatically separates visual images into background and foreground. In the context of the map, the background is typically based map information which shows the spatial context for the thematic content of the map. The figure-ground relationship can be manipulated to distinguish land from water or the thematic content of the map from the base map. The figure 4 shows the basic elements of map. It is imperative to include some description of the location of the features on the map. The location of the map features may be given in the form of geographical or some other well-accepted coordinate system. Besides, the inset map may also be given along with the maps for displaying the location of the map within a larger area on a small scale. Every map must have a source, because this is essential. Every map is a collection of information. All sources of map information must be referenced. The source should include the date, title, author, publisher, and any other known and pertinent information. Projection systems, as discussed in some other topic, that it is essential, and almost all printed outputs of the geographic data is projected onto a flat surface. Since this transformation results in some kind of distortion, it is mandatory that the projection system must be mentioned so as the type and the distortions can be assessed. The statement on the projection should include the name of the projection, central meridian, zone lines of tangency, the datum, and spheroid. In the case of large scale maps which covers a small area, the map projections may be omitted from the map. On every map there are written components, and these are being differentiated on the basis of the size and the characteristics of the text. The text, their stretch, their position highlights the significance of the particular feature. There are several text characteristics that can be manipulated by the map designer. Text style is commonly used to distinguish between different types of features. For example, upright characters are generally used to represent land features, while italics are often used to label water bodies. The form of text characters can be used to indicate the relative importance of features. Form refers to the text fonts. Although there are many fonts available, they can be grouped into two broad classes, serifs and sans serifs. Serifs are semi-structural details on the ends of the sum of the strokes that make up letters and symbols, also known as Roman. The figure 5 shows the serif letters. Sans serif fonts are the simplest. Arial is the typical example of the sans serif fonts. These fonts are often used on maps to label relatively minor features. A typeface without serif is called sans serif, from the French sans meaning without, also known as Gothic. In traditional prints, sans serif fonts have more typically used for headlines than for body text. Sans serif fonts have become the de facto standard for body text on screen, especially online. The figure 6 shows the sans serif letters. Serif fonts such as Times New Roman may be used to identify features of greater significance. For example, cities might be labeled using a sans serif font, but capital cities might be labeled with a serif font. The size of lettering can also be used to indicate importance. Size refers to both the height of the letters, that is the point size, and their weight, that is the normal or bold. The spacing of the lettering can be used to indicate feature extent. Point and line features are generally labeled using closely spaced lettering, while aerial features are often labeled with widely spaced lettering to indicate their extent and orientation of the features. Placement and orientation of the text is used to indicate the location and extent of features. Text placement highlights the significance of the features. Placement of lettering on maps is more important on reference map that typically labels many geographic features than on the thematic maps. On thematic maps, text is often limited to the title, legend, and other peripheral information. Labeling of the features on the map involves trade-offs between locational precision and legibility. Placing of label points on a map is an important component of map design as they provide the greatest flexibility to attach descriptions to point, line, and area features. When properly placed, the lettering clearly indicates the phenomena to which it refers. In contrast, poorly placed label may carry some other meaning. For making a map compatible and meaningful, standardized formats for label placements has been developed. Some general rules for text placements are legible and easily associated with the features they describe. Don't break names, don't extend names along rivers or other line features. If possible, place river names in downstream direction. Closely associate names with features. Don't bend names excessively. Place so as to show the extent of the features. Reflect the hierarchy of features by the use of different font sizes. Not be densely clustered nor evenly dispersed. All these are shown in figure 7. Names should be either entirely on the land or on the water. Lettering should generally be oriented to match the map orientation. That is, it must be parallel to the upper and lower edge of the map for the large scale and parallel with the parallels for the small scale maps. In case of conflict between lettering and data, the data should be interrupted, not the names. Care must be taken that there is no overposting, that is overlap, though labels must be positioned to avoid overposting but without destroying the eye's ability to associate labels with appropriate features. For point labeling, there are certain rules. Optimum position for a label is above and to the right of the point. Below and to the right is less acceptable. The least acceptable position is to the left and the below of the point. Label can be turned non-horizontal if necessary, but only by a small amount. Figure 8a shows the point labeling. Procedures. Polygon labeling. Labeling of polygons within automated mapping is difficult and challenging programming problem. The label should be central to the feature, may be reoriented or curved to fit the feature. In some cases, the label may be connected with the features by an arrow. Another way of labeling is the diagram labeling. Labeling of the diagram is generally a matter of trial and error. Search for feasible positions for a rectangle wholly enclosed in the polygon. The ratio of the width to the height should be as high as possible. If the nature of the data suggests the shape of the graphic, follow that suggestion. Otherwise, move towards horizontal graphics about 15% wider than tall. While mapping, always follow the traditional cartographic symbols and colors. For example, water in blue color, forest as green, contours in brown, grid lines in purple, cropped areas as yellow, etc. By straying from these traditional methods of symbolization, the map may be misinterpreted. Thank you very much for your patience.